All right, let's just jump right in. In this explainer, we're going to totally demystify the invisible, yet absolutely monumental engineering that powers the world's biggest streaming service. I mean, you use it all the time, right? But the fact that it accounts for nearly 15% of the world's entire internet traffic is just mind-blowing. So let's pull back the curtain and look at the sheer scale of what's actually happening behind the scenes.
The next time you sit down to watch a show, I really want you to ask yourself this exact question. What is happening in that massive digital journey behind the screen? Because we totally take for granted that the video just plays, but what is actually going on in that tiny, tiny window of time?
Well, the clock starts now. In literally just 2 seconds, thousands of services, AI models, and cloud systems have to perfectly sync up to deliver that very first frame of video. It's this insane choreographed dance of data happening at lightning speed. And today, we're going to break down exactly how it works.
So, here is the game plan. We're going to follow the microsecond journey of a user session through 5 critical layers: the 2-second connection, AI and homepage gen, processing and streaming, microservices and event streaming, and finally, security, DevOps, and observability. Let's get to it.
Layer 1, the 2-second connection. Focusing on the initial request, let's see how this all builds. Starting the exact microsecond, your device reaches out to the global internet.
In a fraction of a heartbeat, your request races through GeoDNS in Anycast routing. Think of this as basically the internet's ultimate GPS. It's desperately trying to find the absolute fastest path to an AWS-hosted API gateway. Every single millisecond counts here. The system instantly calculates your geographical location just to make sure your connection takes the most efficient global route possible. But before letting you in, the system has to check your ID at the door, right? It instantly validates your device using these incredibly fast cryptographic protocols. It checks your session via OAuth2, verifies your active subscription, and it even fingerprints your specific hardware. And the best part? All of this is wrapped in strict TLS 1.3 encryption, so your data is completely locked down from the jump. Moving on to Layer 2 AI and homepage generation. Now that you're securely authenticated, let's look at how the gateway orchestrates a unique AI-driven homepage rendered specifically for you. What's really fascinating here is how your highly granular habits feed into massive deep learning models. I mean, think about it. The system knows exactly when you hit pause to go grab a snack. It's not just looking at what you watched, it's analyzing your search history, your device type, and these microscopic behavioral triggers to assemble a profile tailored for this exact moment in time.
And this brings us to collaborative filtering. The AI essentially knows what you want to watch before you even do. By matching your specific habits with global viewer trends, deep learning models analyze patterns from millions of people just like you. It's constantly running background A/B tests to rank titles so effectively that it dramatically slashes your scrolling time.
Layer 3, processing and streaming video. So you've clicked a show based on those spooky good recommendations. How on earth does that massive video file get to your screen without buffering?
Well, a pristine master file goes through a really rigorous pipeline. It literally shatters into thousands of different chunks and resolutions. It's instantly transcoded into multiple formats and sliced up to create what's called adaptive bitrate ladders, which is really just a fancy way of saying they have different quality versions of the exact same video ready to go. Finally, it's packaged into standard streaming formats.
But having the video ready isn't enough. It has to be close to you. And here is a crazy fact. The platform actually places physical OpenConnect storage servers right inside your local internet service provider. So when you hit play, that data isn't crossing an ocean. It's coming from a cache sitting literally right down the street, which almost entirely eliminates latency. And while you watch, this adaptive bitrate streaming logic acts as the silent hero that prevents the dreaded buffering wheel. If your network suddenly drops, the logic senses it immediately and requests lower resolution chunks. Once your connection stabilizes again, it seamlessly ramps back up to those pristine 4K chunks. You probably don't even notice it happening.
Layer 4, microservices and event streaming. Let's take a quick peek behind the curtain at the invisible web of tiny, independent programs that makes all of this possible. By breaking the platform into independent microservices, it means a crash and, say, the billing system won't stop you from finishing your movie. Instead of one massive, fragile application that could take down the whole ship, the architecture relies on hundreds of specialized services. Everything from managing subtitles to processing your downloads operates completely on its own.
And because these services have totally different needs, the engineers use polyglot persistence, which, okay, sounds super academic, but it basically just means they choose completely different database technologies based strictly on the job at hand. You've got a relational database handling the billing, a wide column store managing massive viewing histories, Redis for lightning-fast caching, and Elasticsearch powering your rapid search results. It's all highly specialized.
Connecting all of this together is Apache Kafka. See, every single action you take generates a telemetry event. It's essentially a digital footprint of your plays, pauses, and rewinds, sent straight through Kafka topics. These events instantly feed real-time analytics and data processing engines, which is exactly how the system constantly learns and heals itself on the fly.
Finally, Layer 5, Security, DevOps, and Observability. For our last layer, let's explore the invisible shield and the command center keeping this massive distributed system alive and totally secure. Engineers use infrastructure as code and Kubernetes to silently auto-scale servers millions of times a day without ever interrupting your stream. Through some pretty sophisticated CI/CD pipelines, new code is deployed using canary rollouts. You know, like a canary in a coal mine. They test the waters with a tiny fraction of users before pushing an update out globally.
And security? It is baked into literally every layer. We're talking encrypting the video on the fly with DRM technologies, all the way to automatically blocking massive DDoS attacks at the edge. A web application firewall stands guard, while strict identity and access management ensures least privilege across the network. All of this is backed up by continuous vulnerability scanning. To monitor all of this chaos, a really complex observability stack gives engineers a god's eye view of the whole operation. They use distributed tracing to pinpoint microsecond delays long before they trigger a real incident. Tools like Prometheus track vital metrics, while the ELK stack manages the overwhelming flood of logs, just ensuring the service is absolutely flawless.
When that 2-second clock finally stops and your video starts playing, just remember this powerful summary of the sheer scale we just explored. One tap triggers one of the world's most advanced distributed systems. It's an absolute triumph of modern software engineering.
I really hope this explainer leaves you marveling at the perfectly orchestrated engineering happening right behind your screen. So next time you hit play, are you just going to see a movie, or are you going to see a billion data packets dancing in perfect synchronization? Until next time, keep exploring the hidden systems that shape our digital world.